What is time? Is it a steady, unchanging flow that moves us from the past to the future? Or is it something far stranger than we can imagine? Time governs every aspect of our lives, our days, our decisions, our very understanding of the universe. But when we examine time through the lens of physics, it starts to unravel into something much more mysterious. Today, we're diving deep into the science of time to uncover how it works, what it really is, and whether it even exists. At first glance, time feels simple. We measure it with clocks and calendars, and we feel it passing every second. But in the grand scheme of the universe, time is far from simple. In fact, modern physics suggests that time as we experience it might be an illusion. Let's start with Einstein's groundbreaking theory of relativity, which forever changed how we think about time. Einstein showed that time isn't separate from space. Instead, it's part of a four-dimensional fabric called spacetime. In this model, time and space are interconnected, and they can be warped by mass and energy. Massive objects, like planets or stars, bend space-time around them, and this bending doesn't just affect space, it affects time as well. This phenomenon is called gravitational time dilation. Here's an example. Imagine two clocks, one on the surface of the Earth and one far out in space. The clock closer to the Earth, where gravity is stronger, will tick more slowly than the clock in space. This isn't just theory, it's been confirmed by experiments. In fact, the GPS satellites we use every day experience time dilation because they're farther from Earth's gravity. Their onboard clocks tick slightly faster than clocks on the ground, and engineers have to account for this difference to ensure accurate positioning. But gravity isn't the only thing that affects time. Einstein's theory of special relativity reveals another bizarre property. Time slows down for objects moving at high speeds. If you were traveling close to the speed of light, time would pass much more slowly for you than for someone standing still. This effect, called velocity time dilation, has been demonstrated with high-speed particles and even atomic clocks placed on fast-moving airplanes. The faster you go, the slower time becomes. These discoveries lead to an astonishing conclusion. Time is relative. It's not a universal constant ticking the same way for everyone. Instead, your experience of time depends on your position in space-time and your speed. This challenges our everyday understanding of time as something absolute and unchanging. But it gets even stranger. If time can be stretched and slowed, could it stop altogether? Near a black hole, this question becomes incredibly compelling. Black holes are so massive that they warp space-time to an extreme degree. As you approach the event horizon, the point of no return, time appears to slow down infinitely for an outside observer. From their perspective, you'd seem frozen in time. But from your own perspective, time would continue as usual and you'd fall right through. The deeper you go, the more distorted time becomes, until you reach the singularity, where space-time and our understanding of physics completely breaks down. Black holes aren't the only places where time behaves strangely. Let's rewind to the very beginning of the universe, the Big Bang. The Big Bang theory suggests that time, along with space, began about 13.8 billion years ago. Before that, there was no before, no time, no space-time, nothing. This raises profound questions. Did time truly have a beginning? Or has it always existed in some form? Could time even be cyclical, endlessly looping through big bangs and big crunches? Some physicists argue that time might not exist at the most fundamental level of reality. Instead, it could be an emergent property, something that arises from deeper physical processes, much like temperature emerges from the collective behavior of molecules. Quantum mechanics, the science of the very small, adds weight to this idea. At the quantum level, particles don't follow a strict timeline. They can exist in multiple states at once and seem to move both forward and backward in time. This quantum weirdness suggests that our linear experience of time might be just a useful approximation, not the ultimate truth. Then there's the block universe theory, which flips our perception of time on its head. In this view, all moments in time, past, present, and future, exist simultaneously. Imagine time as a block of space-time, where every event is already set, like scenes in a movie reel. We perceive time as flowing forward because of how our brains process information. But in reality, the future might already exist, and the past might never truly disappear. If this is true, it raises an unsettling question. Do we really have free will? If the future is already out there, are our choices predetermined? While the block universe suggests that everything is fixed, it doesn't necessarily mean we're powerless. Our actions might still be embedded in spacetime. They're just part of the fabric of the universe, like everything else. And what about time travel? If time is flexible and relative, could we bend it to travel into the past or the future? General relativity allows for theoretical possibilities like wormholes or closed time-like curves, where time loops back on itself. But time travel comes with its own set of problems, like the famous grandfather paradox. What happens if you go back in time and prevent your own existence? These paradoxes remain unresolved, and even if time travel is theoretically possible, it might always remain beyond our reach. So does time really exist? It depends on how you define it. On one level, time is a practical tool, a way to measure change and structure our lives. But on a deeper level, time is a concept that bends, stretches, and even vanishes under the strange rules of physics. Whether it's an illusion, a fundamental property of the universe, or something else entirely, time remains one of the greatest mysteries we've ever encountered. As we continue to explore the nature of time, we're not just learning about the universe, we're learning about ourselves. Our perception of time shapes how we live, think, and experience reality. The more we study time, the more it challenges our understanding of existence. And maybe that's the most fascinating thing about time. It's both familiar and profoundly alien, slipping through our fingers even as it defines everything we do.